All right, section 10.3.4, review and preview, problem 153. From a batch of 500 light bulbs, how many ways can 3 be tested to see if they are defective? So out of all these light bulbs, we're going to choose 3 light bulbs, and we don't care the order, right? So if we don't care about the order, this is a combination. So we have 500 light bulbs. We're going to choose 3 of them. And let's remember our equation for combinations. We have 500 factorial, which is a very large number, over 500 minus 3, so 497 factorial times 3 factorial. And I'm going to write my 500 in a kind of special way. I'm going to write it as 500 times 499 times 498 times, 497 factorial, all over 497 factorial times 3 times 2 times 1. Okay, and I wrote it this way because, look, 497 factorial cancels in the top and the bottom. And I am left with 500 times 499 times 498, all over 3 times 2, or 6. And on my calculator, I'm wondering, okay, can I simplify this at all? And it turns out that 498 divided by 6 is 83. So if I multiply 500 times 499 times 83, I get a very big number of 20,708,500. That is a lot of ways I could choose 3 light bulbs from 500. Okay, let's look at problem 54. There's a lot of words here. All right, Mr. K wants to bring a variety of language textbooks to the classroom in which he teaches French. From his library at home, he found some that would be appropriate for the classroom. 4 Russian texts, 7 German texts, 1 Japanese text, 2 Italian texts, and 3 Danish texts. If he decides to bring 1 book of each language to the classroom and put them in alphabetical order by language on his bookshelf, Danish, German, Italian, and then Japanese and Russian, how many different ways can Mr. K arrange the new language books? Okay, so how many ways could he choose? So we have 5 books, right? 1 for each of the languages. And how many ways could he choose his Danish textbook? Well, he has 3 of them, right? And how many ways could he choose his German textbook? 7, because he has 7 German books. How many Italian? He has 2 Italian books. Japanese, 1 Japanese book, and 4 Russian textbooks. So I'm going to multiply those numbers together, 3 times 7 times 2 times 1 times 4, and get 168 different ways that he could choose 1 Russian text, 1 German text, and so forth. Okay, let's look at problem 155. Joachim is getting a new locker at school, and the first thing he must do is decide on a new combination. The 3-number locker combination can be selected from the numbers 0 through 21. So let's remember that 0. So for part A, how many different locker combinations can Joachim choose if none of the numbers can be repeated? Okay, so using a decision chart here, we want to choose 3 numbers. How many ways could we choose our first number? Well, we can choose from 0 through 21. All right, so this is a little bit tricky. There's 22 numbers there, right, including 0. So we can choose 20, there's 22 options for our first number, and now we cannot repeat. So how many are left to choose from? Now we have 21, and then 20, which gives us 9,240. So we solved that using a decision chart, but we could also think about, is this a combination or a permutation? Well, I have 20 things, and I'm choosing 3 of them. The order matters, and there is no repeats. This is a permutation. So I could think of it that way, right? Okay, a permutation is going to be 22 factorial. Oh, sorry, this isn't 20, that's 22 right there. Let me erase. 22. So 22 factorial over 19 factorial, which is 22 times 21 times 20, right? If I simplify that factorial expression, which gives me the exact same answer. So both using permutations or decision chart, I could find that solution. Okay, so in part B, it says, with your understanding of permutations, combinations, and factorials, decide if the name combination lock is appropriate. Well, what do you think? We decided this was a permutation, not a combination. So we're going to say no, and you could put some words to that, right? It's not a combination, it's a permutation. You could call it a permutation lock, and then you'd sound kind of dorky and mathy, but you could. All right, part C. How many mathematical combinations are possible? Okay, so remember, a combination is no repeats, and order doesn't matter. Okay, so that would be kind of weird for a lock. I'm not sure how that would work. But if we wanted to find a combination with 22 things choosing 2 of them, we would have 22 factorial over 19 factorial times 3 factorial. So let's see, when I can simplify the factorials, I'm left with 22 times 21 times 20, all over 3 times 2 times 1. And let's see, I could divide the 3 into 21 and get 7, and 2 goes into this 10 times. So 22 times 7 times 10, put that in my calculator, and I get 1,540. Okay, let's think about part D. This is interesting. How many choices would there be if you could repeat a number, but not use the same number twice in a row? Okay, so this seems like a decision tree, or decision chart problem. How many ways could I choose the first number? Well, everything's available to me, so I could choose out of 22, I have 22 choices. Now, my second spot, I cannot repeat that first number because it's right next to it. So I'm left with 21 choices. And now in my last spot, let's see, I can't repeat the one that was in spot 2, but I can, this new number from spot 1 is now available to me. So I still have 21 choices. So I multiply these together, 22 times 21 times 21. In my calculator, I get 9,702. Okay, problem 156. This is a checkpoint for finding angles in and areas of regular polygons. It will be referred to as checkpoint 10. This is important stuff. At this point in the course, you should be feeling pretty confident about how to answer these questions. So part A, what is the measure of each interior angle of a regular 20gon? Okay, well, I do know there's several ways you could answer this, right? One is that we could think, I know that the sum of the interior angles of any polygon, regular or not, is 180 times n minus 2. So 180 times 18 gives me the sum of the interior angles, which is 3,240. But I just want to know each interior angle. And there's 20 of them, so I could divide that by the number of angles to get 162 degrees. Is there an alternate way I could do that? Sure, I could think, okay, if I have an interior angle and an exterior angle, they add up to 180, right? I know that the sum of the exterior angles is always 360. So I could say 360 divided by 20 and get 18 for my exterior angle here. Okay, and my interior angle would be 180 minus 18, which is 162 degrees. So either way, we get the same answer. Each interior angle of a regular 20gon is 162 degrees. Okay, now let's think about B. Each angle of a regular polygon measures 157.5. How many sides does this polygon have? So again, I can use either of these relationships that I used in part A. I think using the idea of the exterior angle is going to make my life a little bit easier. So I'm going to say, okay, if the interior angle is 157, an exterior angle is supplementary to that. So 180 minus that interior angle is 22.5 degrees. And I know that the sum of the exterior angles is always 360. So I divide 360 by 22.5 and get 16 sides of my polygon. Okay, part C. Find the area of a regular octagon with sides that are 5 centimeters. Okay, I'm not even going to try to draw the octagon, but I'm going to imagine we slice the octagon into 8 pizza slices, right through the center, which is going to give me a triangle. And I know that the edge of my triangle is 5 centimeters. Okay, so the next thing I want to think about is, what is the central angle in my pizza slice? So there's 360 degrees total in the central angle. Divided into 8 equal parts gives me 45 degrees if I put that in my calculator. So this is 45. And if I knew the area of this pizza slice, I could multiply it by 8 and get the area of the whole octagon. Well, it's a triangle, so I need to know the base and the height to find the area. The height, let's call that h, and make a right triangle there. If I divide my pizza slice into half, let's see, now I know this angle now is 22.5, right? I divided 45 into half. And I know if I divide this base in half, I get 2.5 centimeters. And I can set up a trig ratio, right? I could say tangent of 22.5 equals, here's my angle, opposite over hypotenuse. And 2.5 is opposite of that angle. And I said hypotenuse, but it's not hypotenuse, it's the adjacent. Tangent is opposite over adjacent. The h tricked me. It's height here, not hypotenuse. Okay, now we need to solve for h. I could cross multiply, right? H times tangent of 22.5 equals 2.5, and then divide by tangent of 22.5. To find my height is 2.5 divided by tangent of 22.5 degrees, which is 6.0355. Put that in your calculator. Okay, excellent. Now I know my height, I know my base, and I know my height. So my area of my triangle is 1/2 base, which is 5, times height, which is 6.0355. You could keep the exact value in your calculator. That's the area of this one pizza slice, but how many pizza slices do I have? 8. So I multiply all those together to get a total area of about 120.71 square centimeters. Square centimeters. All right, problem 157. The first 4 factors of 7 factorial are 7, 6, 5, and 4, or we could write it, in this way, 7 times 7 minus 1 times 7 minus 2 times 7 minus 3. All right, so they ask us to do the same thing for 12. So 12 factorial, let's think, is 12 times 11, but I could write that as 12 minus 1, times 10, or I could write that as 12 minus 2, and then one more factor, 9, would be 12 minus 3. Okay, and in part B, the first 6 factors of n factorial. Okay, let's think this is going to be n times n minus 1, times n minus 2, times n minus 3, times n minus 4, times n minus 5. Is that 6? 1, 2, 3. Yep, we got 6 factors of n factorial. And then it would keep going if it was multiplying by, depending on how big n was. Okay, so now it's asking us, what is the permutation n choose 6? Okay, let's remember our equation for permutations. It's n factorial over n minus 6 factorial. Okay, well, I'm going to write n factorial in this special way. N times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 times n minus 6 factorial. All over n minus 6 factorial. Oh, and look what happens. N minus 6 factorial and n minus 6 factorial cancel out, and we are left with just this thing that's kind of tedious to write out. N minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5.